Solving equations involves finding x, finding out what x is. And to do that, we need to undo the calculation, or in other words, we need to do opposites to be able to figure out what x is. So here I have some number plus 3 equals 8. We can kind of guess what that number is, but we can show this systematically by undoing these calculations. So I'm going to undo this plus 3 with the minus 3. Now an equation, the one rule with equations is the left side must balance the right side, and we have to keep it balanced all the time. So if I subtract 3 from this side, I will subtract 3 from the opposite side. And then I just have to keep track of what's on the left side and right side. This is a zero pair. 8 minus 3 is equal to 5. And if I end up with x by itself, I have solved for x. So if I check this answer, x equals 5, if I plug it back in, 5 plus 3 equals 8. So the key ideas in are balance, what you do to one side you have to do to the other, and opposites. We do opposites to show our steps. And we do all our work vertically. With this one here, be careful, do not do 5 minus 2, because this really means times 2x, so this is 2x's, this is 5 ones, we can't combine those together. So the first thing I'm going to do is I'm going to group my like terms together. So that's 5 ones, that's 25 ones. I want to get the 5s on the same side. So I'm going to subtract 5, do an opposite, and I'm going to balance on this side. And we have to keep track of that negative. So when I do this, there's my zero pair. This is a minus 2x, so I have to keep track of that minus on this side. On the right hand side, 25 minus 5 equals 20. Again, notice how I can track all my terms vertically. To get rid of a times by negative 2, I need to divide by negative 2. What I do to one side, I have to do exactly the same to the other. And I'm going to end up with x is equal to negative 10. Okay? So there is solving for equations. It involves balance and opposites. For squares and square roots, I can use my calculator for most of these. The exponent means repeated multiplication. So I can do 3 times 3 times 3 times 3 times 3, or I can use the power button on my calculator. Okay, so if I want, I could convert, make it easier, a step easier, make it into multiplication, but really we should start understanding how to use powers, and also appreciate that powers are not times, they're slightly different. Just like multiplication is repeated addition, we never say that multiplication and addition are the same thing. So same thing happens here. Repeated multiplication is not the same as multiplication. So if I do 3 to the power 4 using my power button, I get 81. Square roots are to do with powers. Okay, they're opposite of power squared, or square power. And if I put this into my calculator, I get 8.54. Now the model we use for one of the powers, for square power, is area and side length. So when I square something, I'm going from side length, for example, a side length of 8. If I square it, I get the area of 64. So the area comes about from the side length squared. So there's my side length inside the brackets. That's a side, and this is area. So the opposite is true. If I'm squaring, going from side length to area, I square root to do the opposite. So I'm going to take my area, I square root, that gives me side length. So inside here is area. The answer to that square root is side length. And so I'm getting a side length of approximately 7.5 745, so I'm going to round that to 75. So this is approximately equal to, and this is not a perfect square, so that's why the approximate is there. It's approximately 7.75.